Good morning, boys and girls.
Today we are going to do lesson 12-3, compare decimals. I can compare decimals by reasoning about their size.
Let's start with the solve and share. A penny made in 1982 weighs about 11 hundredths of an ounce. A penny made in 2013 weighs about 9 hundredths of an ounce. Which penny weighs more? Solve this problem any way you choose. So, Ms. Schultz, what do we need to find here?
So I need to find which penny weighs more, the penny made in 1982 or the penny made in 2013.
So actually, let me bring up these pennies I found. They're from the 2 years we're talking about.
Awesome.
And here are their weights.
So I know that the penny made in 1982 weighs 11 hundredths of an ounce, and the penny made in 2013 weighs 9 hundredths of an ounce.
I notice that you're saying of an ounce. You're not saying ounces. Why is that?
So what I noticed about the weights of both pennies is that neither weights are a whole. Both of them have 0 in their ones place value, which means they're not a whole yet, so they're not even a full ounce. They're part of a whole.
Wow, that's very cool. So in order to find which penny weighs more, what can we use?
So we can use place value to compare decimals.
Let's put our numbers in our chart.
Great. So you can use place value to compare decimals the same way you do when comparing whole numbers. Compare decimals by comparing the digits in the greatest place value first, and then compare the next greatest place value, and so on. So let's look at the chart.
No, I was going to say, how can we do that with this number here?
Great. So let's look at 11 hundredths and 9 hundredths. So looking at the ones place, both of the digits have the 0, so they're equal. We need to now look at the next greatest place value, which is the tens place. There's a 1 in the tens place and a 0 in the tens place. The 1 in the tens place is greater than the 0, therefore 11 hundredths is greater than 9 hundredths.
So now we know that the penny made in 1982 is the one with the greater weight.
Correct. Because 11 hundredths is greater than 9 hundredths.
Let's move on. Can we compare 23 hundredths and 32 hundredths?
We can use place value blocks to compare this time.
Okay, so I have our manipulatives over here. I'm going to bring out 2 longs.
Great, that represents the 2 tenths in 23 hundredths.
And 3 units.
Great, that shows 23 hundredths.
What do I need for 32 hundredths?
So for 32 hundredths, you're going to need 3 longs for 3 tenths, which would also equal 30 hundredths. And then you'll need 2 unit cubes for 2 hundredths. Perfect, now you have 32 hundredths. So I can tell just by looking at both of the manipulatives, both sets of manipulatives, that 32 hundredths has more pieces than 23 hundredths. So I'm going to say that 32 hundredths is greater than 23 hundredths, or 23 hundredths is less than 32 hundredths.
Okay.
We can also plug it into our place value chart to check our answer.
So we have 32 hundredths and 23 hundredths.
Great. And if I use place value in the ones place, both numbers have a 0. Then I look in the tens place. One digit has a 2. One number has a 3. 3 is greater than 2, which means 32 hundredths is greater than 23 hundredths.
Great. Let's try some more examples.
Okay, so we have $2.98 and $2.56. Again, I can use place value. So why don't we plug these numbers into our chart? Let's start with $2.98.
Let me put that right here. And this will go right underneath.
Great. So if I'm using place value to compare, I'm going to start in the greatest place value, the ones place. Both numbers have a 2 in the ones place, so they're equal in the ones place. Then I move to the tens place. There's a 9 and a 5. Well, I know 9 is greater than 5. So $2.98 is more money than $2.56. So it should be $2.98 is greater than $2.56. Let's try another one. Here we have 3 and 40 hundredths and 3 and 4 tenths. Let's plug those into the place value chart. Okay, so this time when I compare place values, I look in the ones place, they're equal. Tens place, they're equal. And then I notice in the hundredths place, one number has no digit and the other number has a 0. So they're equal in all place values. I also know that 0 has no value. So I can also add a 0 as a placeholder in 3 and 4 tenths, which would make them equal because the ones place is equal, the tens place is equal, and the hundredths place is equal. I also know that 4 tenths is the same as 40 hundredths.
Yeah, awesome. What about the next one? 8 hundredths and 7 tenths.
Okay, so let's plug in to our place value chart so that we can compare place values. Okay. Okay, so again, starting in the greatest place value, the ones, they're equal. In the tens place, 7 is greater than 0. So 7 tenths is greater than 8 tenths. So to complete the sentence, 8 hundredths is less than 7 tenths.
Awesome. Let's look at the next one. I'm wondering if our students can try the next two on their own.
I think so.
Okay, let's look at $21.50 and $21.99. Oops, I'm sorry.
Okay, so the first one we have $21.50. And the second one we have $20.99. So starting in the tens place this time, which is the greatest place value, they're equal. Then I move to the ones place and I notice that there's a 1 and a 0. Well, 1 is greater than 0. So $21.50 is greater than $20.99.
That one was a little tricky because the 99 seemed like a greater amount.
Yeah, but if you follow the rules of place value and comparing, and if you start with the greatest place value, you wouldn't even get to the 99 to compare.
Yeah, let's look at the next one. 41 hundredths and 14 hundredths.
These look tricky.
Let's follow the rule.
Okay, so looking at the greatest place value, the ones place, both have a 0. Moving on to the tens place, 4 is greater than 1, which tells me that 41 hundredths is greater than 14 hundredths.
Looking at and following the rule makes it so easy, Ms. Schultz.
Definitely.
Let's go to the next example.
Okay, here we have our higher order thinking question. Tori has 2 different sized water bottles. In the larger bottle, she has 81 hundredths liter of water. In the smaller bottle, she has 1 and 1/10 liters of water. Can you tell whether one bottle has more water? Explain.
Well, Ms. Schultz, we don't even really need to look at the numbers. Just check the picture. The one on the right is much bigger than the one on the left.
True, Ms. Ortiz, but make sure you read the question carefully. It says, can you explain whether one bottle has more water? So we're not
Oh,
comparing the size of the bottles, but we're comparing the amount of water in each bottle.
let's use our place value chart.
Definitely. Okay, so using our rules of place value and comparing and starting in the greatest place value, we notice that one number has no place value in the ones place, but we can add a 0 as a placeholder, which does not change the value. 1 and 0, well, 1 is greater than 0. That tells me that 1 and 1/10 liters is greater than 81 hundredths of a liter.
So that must be the bigger bottle.
Yes, I also,
Sorry, the bottle that has more water.
yes, I also noticed that 1 and 1/10 liter is more than a whole because it has one whole.
We could also tell that by checking out here it says liters and this only says liter.
It's like a little clue.
So what's our answer to this question?
So the answer is, can you tell whether one bottle has more water? Explain. Yes. The smaller bottle, even though the bottles are different sizes, you were comparing the number of liters of water. So the smaller bottle has more water in it. 1.1 liters is greater than 81 hundredths of a liter.
I'm just going to add one quick thing here.
Perfect.
And there you have it, 2-3.
Don't forget, guys, if you need help, check us out on our Google Hangout.